Next equation we use is Newton's experimental law, NEL for short. E is equal to minus V1 minus V2 over U1 minus U2. And again, this is along the I direction only. We fill it in. This gives us E is minus V1 minus V2. We get these from the table. It's P minus Q. Over U1 minus U2. These are also on the table. U1 minus U2, U over root 2. Minus U over root 2. Our E is equal to, multiplying the minus P plus Q above the line over 2U over root 2. Finally, minus P plus Q is equal to 2 U E over root 2. And maybe we can tidy that up a little bit. 2 over root 2 is simply root 2. So we can just say it's root 2 in front. And we get minus P plus Q is root 2 UE. And we call this equation 2. And this is now our second simultaneous equation, 1 and 2. Back to our steps, and we see now we're on to the fourth step, which is to solve these two equations. So write them down again. P plus Q equals 0 is the first equation. And the second equation we just derived, minus P plus Q is equal to root 2 times UE. And we solve these so the p's cancel, and we get 2Q is root 2 UE. Q is equal to root 2 UE over 2. And divide above and below by root 2, and you get UE over root 2. And we can start again. This time we can maybe multiply the second equation by minus 1 to solve for P. P plus Q equals 0. P plus Q equals 0. Second equation becomes P minus Q equals minus root 2 UE. And this time the Q's cancel, and we have 2P is equal to minus root 2 UE, or P is equal to minus root 2 UE over 2. And again, dividing above and below by root 2, this gives us P is equal to minus UE over root 2 over root 2. Just fix that. Now, there's one extra little step here, and that is to find the speed of each sphere after the collision. So to find the speed, we first have to be clear on what the velocity is. So the first sphere is called A, so let's call that dA. And to get that again back to our table, and the speed of the first guy after collision is Pi, or sorry, the velocity is Pi plus U over root 2J. And now we can fill in P because we just worked it out. P is minus UE over root 2 times I plus U over root 2J. Now I have to draw a rough diagram to just see what this might look like, and we can see that it's minus in the I direction, so it's going to look like this. It's a minus component in the I direction and the plus component in the J direction. So minus and plus. So these are the components, so the velocity will look something like this. This will be VA. So here's the velocity, magnitude and direction. We're looking for speed, however, which is direction only, which is magnitude only. So speed means get the length of this hypotenuse here, and the method for getting speed is first of all we give this notation, which is modulus, and the method for hypotenuse is to get the square root of the I component squared and the J component squared. Plus the J component squared, which is U over root 2 squared. And that's, as we said, that's speed. Now working this out gives us U squared E squared over 2 plus U squared over 2. Write it all over 2 gives us, we can take out the U squared outside as just simply U, and we get E squared plus 1 over 2. And maybe even take out the 2 outside the square root, and you get U over root 2 into E squared plus 1. And that's the speed of the first guy calculated. Now let's look at B for a minute. Velocity of B after the collision. And back to the table, just to remind ourselves, it's Qi plus U over root 2J. Which is, we just worked out Q, UE over root 2 along the I direction plus U over root 2 in the J direction. Now just by comparing VB with VA up here, you'll see the symmetry. The magnitude is the same of the I component, and the J component is just the sign. So the speed is going to be the same. So we can, just by symmetry, we can say that the speed of B is the same afterwards. So the magnitude of VB, we don't have to work it out again, is the same as the first, as A, this one here, which is U over root 2 into E squared plus 1. Okay, so that's the two speeds that we were asked for in part I of the question. So just to label that.